Have you ever paused to consider the bustling world of microscopic life that lies within your compost heap? Just beneath the surface of your garden, an unseen marvel is at play. A world teeming with life and activity, a world as intricate and vital as any cityscape, forest, or ocean. This is the hidden world in compost, the bustling metropolis of microscopic life that transforms our waste into a rich and fertile soil. Compost, as many of us know, is a natural way to recycle organic material. It's made up of things like fruit and vegetable scraps, coffee grounds, yard waste, and yes, even that newspaper you've finished reading. When these materials are combined and left to decay, they form a rich, dark, crumbly substance that gardeners affectionately call black gold. But how does this transformation occur, you may ask? Well, the answer lies in the microscopic life dwelling within the compost. They are the unsung heroes, the tireless workers that break down organic material into its basic components, creating a nutrient-rich environment for plants to thrive. In compost, you'll find a diverse array of these microscopic organisms. They include bacteria, the most abundant and industrious of the compost citizens, fungi, which break down tougher materials like wood and straw, and protozoa, who feed on bacteria and help maintain a healthy balance of nutrients. And let's not forget the nematodes, tiny roundworms that contribute to the decomposition process by feeding on bacteria, fungi, and other microscopic life. They're the predators of our compost story, keeping the population in check and contributing to the ongoing cycle of life and decay. This hidden world in compost is a remarkable ecosystem, a testament to the power and complexity of nature. It's a world of cooperation and competition, of life and decay, all happening right under our feet. So the next time you toss a banana peel into your compost bin, remember the bustling world you're contributing to. As we delve deeper into this topic, we will discover the vital role these tiny organisms play in the creation of compost. Our first group of microscopic heroes are the bacteria, the most abundant microorganisms in compost. Bacteria are the primary decomposers in the compost pile. These minute life forms are the unsung heroes of compost, tirelessly working to break down organic matter into its constituent parts. They may be invisible to the naked eye, but their impact is anything but small. Now you might be asking, how exactly do bacteria break down organic matter? Well, in essence, they eat it. Bacteria consume the organic material, breaking it down through a process called decomposition. This involves various chemical reactions that ultimately transform complex organic materials into simpler substances. During this process, bacteria produce heat as a byproduct. This heat is critical to the composting process as it helps to speed up decomposition and kill off any potential plant diseases or weed seeds that might be lurking in the compost. So, next time you're turning your compost pile and it feels warm, you know who to thank. But that's not all bacteria do. They also produce another important byproduct during decomposition: nutrients. As bacteria break down organic matter, they release essential nutrients such as nitrogen, phosphorus, and potassium. These nutrients are vital for plant growth, and are one of the main reasons why compost is such a fantastic soil amendment. In a way, you could say that bacteria are the chefs of the compost pile. They take raw, unappetizing organic waste and transform it into a nutrient-rich feast for plants. And they do this all without any need for recognition or reward. They simply go about their work, silently and efficiently, making our gardens healthier and more productive. So, let's take a moment to appreciate these microscopic chefs. They may be small, but their role in the composting process is enormous. Without bacteria, our compost heaps would be nothing more than heaps of waste. Their contribution is truly invaluable. Next in line, we have the fungi and the actinomycetes, the primary decomposers in our compost. These microorganisms are the real heavy hitters in the composting process, quietly and efficiently breaking down the more difficult components of our waste. Fungi, you may know, are neither plant nor animal, but a kingdom all their own. They exist as microscopic cells that grow as long threads or strands called hyphae, which collectively make up the mycelium. In the compost pile, fungi are primarily responsible for decomposing complex carbon compounds. Their mycelium works like a biological drill, penetrating tough materials and breaking them down into simpler substances. Now let's talk about actinomycetes. These are a type of bacteria, but they share characteristics with fungi. Like fungi, they grow as long, thread-like cells. But unlike fungi, they are even more versatile in what they can decompose. They have the remarkable ability to break down even the toughest materials like cellulose and lignin, which are components of plant cell walls. These substances are resistant to decomposition, but not to the tenacious Actinomycetes. They essentially pick up where other decomposers leave off, ensuring that nothing goes to waste in the compost pile. The role these decomposers play is crucial. By breaking down tough organic materials, they help to create humus, a rich, fertile material that improves soil structure, water retention, and nutrient availability. This process is nature's way of recycling, turning waste into a resource that helps plants grow. So, the next time you toss your kitchen scraps into the compost bin, take a moment to appreciate the hard work that's about to happen on a microscopic level. Each piece of waste will be broken down, bit by these tiny, diligent decomposers. Fungi and Actinomycetes are the unsung heroes of our compost, working tirelessly to break down the tougher organic materials. They're nature's little recyclers, turning waste into wealth, and playing an essential role in the circle of life. Last but not least, we have the protozoa and nematodes, the recyclers of our compost ecosystem. These seemingly small and insignificant creatures play an underrated yet vital role in the grand scheme of the composting process. Let's start with protozoa. These tiny single-celled organisms are one of the most prolific recyclers in the compost heap. You might not see them with the naked eye, but under the microscope, they're a bustling, active part of the compost's microscopic community. Protozoa primarily feed on bacteria, absorbing nutrients from them and releasing the excess into the compost. This recycling of nutrients makes them readily available for plants to absorb, facilitating plant growth. Next up are the nematodes, or as some like to call them, the roundworms of the compost world. These microscopic creatures are a force to be reckoned with. They feed on bacteria, fungi, and sometimes even other nematodes. Their dining habits serve a dual purpose. They not only recycle nutrients but also help control the population of other microorganisms in the compost. By keeping the bacterial and fungal populations in check, nematodes ensure that no single organism dominates, promoting a balanced and healthy compost ecosystem. But it's not just about nutrient recycling and population control. Both protozoa and nematodes also contribute to improving the structure of the compost. As they move through the compost, they create tiny channels that improve aeration and drainage, making it a more hospitable environment for other beneficial organisms and ultimately, for the plants. So the next time you're turning your compost heap or spreading it around your garden, remember the tiny recyclers working tirelessly beneath the surface. They might be small, but their impact on the compost ecosystem is immense. They're the unsung heroes of composting, turning waste into a rich, fertile soil that nurtures your garden. The balance maintained by protozoa and nematodes is crucial for a healthy compost heap. So let's give a round of applause for these tiny recyclers, the protozoa and nematodes, for their tireless efforts in maintaining the compost's balance and vitality. So, why is all this microscopic activity so important, you may ask? Well, let's take a moment to recap what we've learned so far. This bustling microscopic world within your compost heap is teeming with different types of microorganisms, each performing a vital role in the composting process. First, we have the breakdown squad, the bacteria and fungi, which kickstart the process by breaking down the organic matter into smaller pieces. Then, the decomposers step in. These are the protozoa and nematodes which consume the bacteria and fungi, releasing essential nutrients in a form that plants can use. Finally, the recyclers, primarily earthworms and beetles, further break down and mix the compost, enhancing its structure and fertility. Each of these tiny life forms contributes significantly to soil health. They enrich the soil with nutrients, enhance its structure, increase its water-holding capacity, and even help suppress plant diseases. What's more, they transform your kitchen scraps and garden waste into a dark, crumbly substance known as black gold, a highly valuable resource that boosts plant growth. But the benefits of composting extend beyond your backyard. By composting, you're not just creating a nutrient-rich soil amendment for your plants, you're also helping mitigate climate change. How so? Composting reduces the need for chemical fertilizers, many of which are produced using fossil fuels. Moreover, compost acts as a carbon sink, absorbing carbon dioxide from the atmosphere. In essence, the microscopic life in your compost heap is doing much more than just breaking down waste. It's creating a cycle of life, converting waste into nourishment and helping sustain the environment. The humble compost heap is in fact a microcosm of nature's perfect recycling system. Next time you look at your compost heap, remember the microscopic world within, working tirelessly to recycle waste into a valuable resource.